in this video, let's talk about how to make a sketch of a rational function. So rational means that it is made up of a ratio, and the ratio means division, and the two things that are divided by are the polynomial on the top and a different polynomial on the bottom. So here, for example, we could have 3x divided by x minus 2. Both the top and the bottom are polynomials. They're both linear functions. So this could be an example of what we might have to sketch. And we will do this same example at the end of this video. So the process that we use to sketch the graph is different. It depends on the person who does the sketch or the instructor who is asking for a particular type of information. So these 6 items that are listed here on the list are common things that people ask. Sometimes some of them are asked and some of them are not asked. You might need to provide a few other pieces of information as well. But the first thing to do is to make a sketch with a graphing calculator and then look for these items on a calculator to see what the answers might be. That will give us a clue if there is any difference between our work by hand and what the calculator shows. Then we would see that on the calculator, hopefully, and be able to spot it and know exactly which part of the math needs to be adjusted to make a better, more accurate picture. The intersects are the places where your graph crosses the x-axis and the y-axis. The asymptotes are the lines, these are imaginary lines that the graph will approach, but it will not cross. It will never cross the vertical line. It may cross horizontal or oblique, but eventually your graph will get very close to these asymptotes. And behavior simply says what happens to the picture, to the graph, as x gets far to the right. So as we go all the way to the right, and as x goes to the left, what happens to the picture? Is it going up? Is it going down? Is it flattening? What's happening? If we have a few other pieces of information that we might need to collect, sometimes plugging in some values into the function and collecting extra points might help. So these are the 6 things that people are often asked. Of the 6 things, the most important are the first, make an educated guess, know what the intersects are, know what the asymptotes are. So these are the key, and the other ones are supplementary. So let's look at sketching of our original example, 3x divided by x minus 2. So here is the question, make a sketch. Now, the first thing we do is we have a look at the diagram with a calculator. And so here is the calculator, and we type in 3x divided by, and then x minus 2 is in parentheses because we're dividing by both x and the 2. So here is the graph. And we can see that the picture breaks here and here. So these would be our asymptotes that we would need to provide to get the more accurate sketch. We see the intersect crosses through 0, 0, and we also see the end behavior. As x goes far to the right, the picture seems to be flattening out, and as we go far to the left, the graph also seems to be flattening out, and that again will come from the asymptotes. So let's get the intersects. So to find, now we've looked at the diagram, we can talk about the domain and range if we need to. Let's look at the intersects. To find the y-intersect, we'll make x equal 0. And if x is 0 in our original sketch, in our original equation, then we have y is 0 divided by 0 minus 2, which is 0 divided by negative 2, which is 0. So our y-intersect is 0, comma 0, because if y is 0, then so is x. So on the sketch here, we can make a little coordinate axis and we can collect the information as it appears. So we now know that the y-intercept is 0, 0, which is right here. The x-intercept, to find the x-intercept, we make here, to find the x-intercept, we make y equals 0. And if y is 0, then we have 0 equals 3x, x minus 2. And to solve this, we can cross multiply. We can also see that the only way to get ratio to be equal to 0 is if the top piece is 0. So the bottom doesn't even matter because 0 over anything is 0. But if we cross multiply, we come to the same solution. 0 times x minus 2 equals to 1 times 3x, which means 0 is 3x. Dividing both sides by 3, x is 0, which gives us the same exact point, 0, 0, that we already had. So these are the intersects. The next part is the asymptotes. The vertical asymptote cannot be crossed. And to find it, we look for the denominator equal to 0. Denominator is the bottom of our function, equal to 0. So if we make the denominator here equals to 0, then x minus 2 is 0. That means x equals 2. So each time x turns to 2, we are going to be dividing by 0, which is impossible. So when x hits 2, our picture will break, and this will be our vertical asymptote. So as when x gets to 2 here, we will have a vertical line that cannot be broken. And the asymptotes are written, usually drawn as a dotted line. It should be more or less vertical, but the main idea is that it should be something like this. So this is the x equals 2, and it's a vertical, imaginary vertical line that our picture will not cross. Now for the other asymptotes, the horizontal, both horizontal and oblique can be crossed. So for the horizontal, we look for the degree on the top and on the bottom. So if we look at the highest power on the top and on the bottom, and we compare those numbers. So if the top happens to be less, top power happens to be less than the bottom, then our horizontal asymptote is y equal 0. If the top equals to the bottom, then our asymptote is y equals ratio of leading coefficients. So for us, the highest power on the top is 1, that's 3x to the 1, and the bottom also 1. So both top and bottom powers are the same, which means we have the second case, and we'll look for the ratio of the leading coefficients. The leading coefficients are 3 and 1. So the horizontal asymptote is going to be y equals 3 over 1, which is 3. So 1, 2, 3, somewhere through the 3 there will be a horizontal line that is our asymptote. Now with this we can actually make a sketch because we have all the needed pieces of information. The graph has to go through this dot, but it cannot cross these lines, which means the only way it can go is like this. And on the other side, it'll go like this. Now we could use a table of values to see where the function is. Is it above or is it below? So we could pick any point that is more than 2, like 3, 4, 5, and see, are we above the 3 or are we below the 3? But we don't need to do that, because if we were below 3, then we would have crossed the x-axis again, and we would have had 2 x-intercepts instead of 1. So this piece cannot cross through this side. It has to be above. Otherwise, we get an extra x-intersect, and we didn't see it on our picture in our work. So this is our sketch by hand, and once again, let's compare it to the sketch with the calculator. So here is the calculator work, and here is the sketch. Now, if we wanted to, we can put our asymptotes as guiding lines just for us to see. So here is the x equals 3, and then for the vertical, we will need to go to the draw, which is program, second program, and select vertical and type in 2. That would be the vertical line through axis 2. So here is horizontal, here is vertical. So we can see visually with this diagram that our graph does get very close to our horizontal line. That's why it's flattening out. And it does get very close to our vertical asymptote. These lines should be dotted. They should not be seen as solid lines because they're imaginary. But we need to have them so that the diagram looks correct, so that all the key information is present. And that's it for this video. Thanks a lot for your time. Take care.